Hello friends. In last session we have discussed about the summing amplifiers and closed loop and the open loop configuration we have already discussed. In this session I am going to explain about the frequency response. Frequency response of an op-amp 741. The op-amp 741, the frequency response, first going to explain about the what is the meaning of the frequency response. The manner in which the gain of the op-amp responds to different frequencies is called as a frequency response. It means that if we are giving the different frequencies, frequencies is called as a frequency response they have given. That what do you mean by gain? First one, gain is output by input of the voltage. Correct. The gain A equals to, by the closed loop or open loop configuration, it has quite different. Inverting amplifier, if you want to take that one, minus plus, this is a feedback, RF P naught equals to output, if you want to take that, minus RF by R1 into V, if A equals to minus RF by R1. The manner in which the gain of the op-amp respond to the different frequencies is called as a frequency response. For example, I want to give the RF is 100 kilo ohm divided by R1 is 100. This is get cancels 1000, you can get that. Gain is 1000. The frequency response of the gain is 20 log into A. That is 1000 is means it is a 3. 20 into 3 equals to 60 dB. If you are responding like that, it is a 60 dB response. This is a call it as a frequency versus the dB, decibel. It is called it as a frequency response. Correct? The bandwidth of any circuit is paramount importance that needs to be considered during the electronic circuits designing process. Yes, what do you mean by bandwidth? Bandwidth means it is the frequencies between the two frequencies, higher frequency difference between the two frequencies. That is the higher frequency to the lower frequency. It is called it as a bandwidth. When the designing the electronic circuit, it will be seen that the bandwidth of the circuit is related to the gain. Yes, the bandwidth is related to the gain. When we are drawing the circuit, means it is a circuit, it is in the bandwidth, it is in the frequencies. Versus we have to take that one. Like we can draw the circuits also, right? And when the designing the electronic circuit, we have seen that bandwidth of the circuit can be to the gain. And one more thing is that gain is inversely proportional to the bandwidth. The bandwidth is inversely proportional to the gain, vice versa, right? Means gain is inversely proportional to the bandwidth, right? This is a very important part in this frequency response. And yes, too much gain and the bandwidth will be less. I have already told that they're inversely proportional to the bandwidth. Less gain and the bandwidth that can be achieved much higher. Yes. Now, almost in this statement, what it has told that it is the bandwidth is inversely proportional to the gain, right? Then, as any op amp has limited bandwidth, it is necessary to carefully consider the gain, the bandwidth of frequency response at the outset of the design of any circuit. Operational amplifier themselves, when the operating in open loop mode, only have a very limited bandwidth before the gain starts to fall. However, by using the negative feedback, the huge gain of the amplifiers can be used and ensure that flat response with a sufficient bandwidth is available. And one more thing is that if in the negative feedback, open loop or a closed loop, always it is a gain is inversely proportional to the bandwidth. One by one sentence we have to going to explain about the fourth point. As any op amp has a limited bandwidth, as a 741 also has a limited bandwidth, it is necessary to carefully consider the gain, bandwidth and the frequency response at the outset of the design of any circuit. Means the bandwidth and the frequency response at outset of the design of any circuit. Operational amplifier themselves, when the operating in open loop mode, only have a very limited bandwidth before the gain starts fall to fall. However, by using the negative feedback, the huge gain of the amplifier can be used. I have already explained in the negative feedback what is the use of the negative feedback, what is the use of positive feedback. The negative feedback, it works on that one. It gives the a high gain of the amplifier. That's why we are using the negative feedback, right? With sufficient bandwidth is available. Op amp bandwidth. Op-amp bandwidth. Although op-amp have a very high gain, this level of gain starts to fall at low frequency. The open loop breakpoint, that is the frequency at which the gain has fallen by 3 dB, is often only a few hertz. It is the, you have to see the typical op-amp open loop gain. Open loop gain bandwidth point, it is the minus 3 dB. How it comes in the 3 dB? It is the uh, open loop gain. Open loop gain, it is the 10 raised to 5. It is the open loop gain. With that, if you want to take the gain of it is a 10 raised to 5, it is the 10 raised to 5 into 2, 2 is there, into 5 of the 10 raised to 6 is the frequency. It is in the megahertz. It is in the megahertz. It is in the megahertz. And open loop gain, it is in the 10 raised to 5, it is there in the dB. It is a minus 3 dB. It is the difference. It is, this difference is minus or a plus 3 dB. It is there. Why? Because it is the RMS value is 1 by root 2. It is the minus 3 dB. It is a 0.707. We can cut off frequency for that one. That's why when we are using the semi-log we are multiply by with the minus 3 dB value. Why? Because of this reason, it is the falls down, it is the breakpoint, that is the frequency at which the gain has fallen. The gain has fallen only a few hertz. 3 dB is often only few hertz. The long lived still vary. It is the 741 IC, it is the very long lived still vary. Popular 741 op-amp has open loop breakpoint around 6 Hz. Beyond this response fallen rate is minus 6 dB, means 6 Hz and the 6 dB. That telling. For example, this is the 6 dB and 6 Hz. It is comes like that. This is a frequency versus the open loop voltage gain, and the octave in octave minus 20 dB is in the decades per decades is a 10 and the octave is a 8. Note, an octave is doubling in the frequency and the decade is tenfold increases in the frequency, and therefore these two figures are two ways of expressing the same characteristics. Means that, for example, if you are the 20 dB they have referred that one. This is a circuit, I have already explained about this one. Minus 20 dB, how it comes, it is, sorry, okay, it is the, yes, A equals to minus RF by R1. It is a minus 20 dB, it is a 1100 kilo ohms divided by 20 kilo ohms. If you want that one, it is a 1000. 10,000 means 10 kilo ohm. 10 kilo ohm, 10 kilo ohm that get cancels, only 10 is remaining. It is a 20 log 10. 20 log 10 means it is a 20 dB. You have got it. Means that it all over the things as depends on the, it's all over things, it is depends on the RF and the R1. R1 is a resistance for the open loop gain of the amplifier in the inverting amplifiers. Therefore, the two figures we is to expressing the same characteristics. The characteristics of this whole, it is depends on the this kinds of circuits, the frequency response of the open loop configuration. Yes. Next, and one more thing, gain is always inversely proportional to the bandwidth. Gain is always inversely proportional to the bandwidth. We have to find out the bandwidth by using the voltage gain and the frequencies. Yes, op-amp gain, bandwidth and compensation. How it is there in this graph, we have to see that one. Before we have seen that the minus 3 dB, this red color line, it is the minus 3 dB, and without compensation, it is the how it is there in the confusion. If you see that one, how much they were, with compensation we can give that one is a minus 3 dB. It falls down the frequencies. It is the open loop configuration, we have seen that one. And the without compensation, how does this circuit works, we have to see that one. one of the main one of the main reason why op-amp generally have a low breakpoint is that feature called the compensation is incorporated into the virtually all op-amps. Means that one in the main reason why op-amps generally a low breakdown point, that is the compensation is incorporated into the virtually all op-amps. This frequency compensation is used to ensure that the op-amp remains stable under the all operating conditions. The very earliest op-amp were prone to instability, and as a result compensation was introduced into the virtually all op-amp IC design. As a matter of course, the effect of the compensation breakpoint on the op-amp bandwidth is reduced the breakpoint. This means that if no compensation had been incorporated, breakpoint and the bandwidth would be greater, but the cost is instability. Yes, and the why we are using the without compensation is not used for that one. The without compensation means that had been a incorporated bandwidth. Why we are not using for the this one is incorporated with the breakpoint, and the bandwidth very would be greater, but the cost is instability. That's why we are not the without compensation. It is the minus 6 dB, it is there, it is the higher the frequency. That's why we are using like that, right? Next, effect of feedback on op-amp bandwidth. The effect of bandwidth on the effect of bandwidth on op-amp bandwidth. It is the closed loop and the open loop configuration. It is the closed loop is like that, and the open loop configuration, it is the fall down frequencies like that. The both the concept, it is the um, it depends on the R1 and the RF frequencies, this open loop and the closed loop concept. When the designing the real circuit using an op-amp, negative feedback is used to give the control levels of gain. Applying this feedback unable to vary the very high gain to be trader bandwidth. In this way, very flat frequency response curves can be achieved with the required bandwidth. Closed feedback op-amp of the frequency response. It is the depends on the frequencies are like that, right? It is around nearly 10 raised to 2 means 1000, correct? It is 10 raised to 5. It is the 10 raised to 6. If I want to take the 1000 kilohertz, this is the RF feedback resistance. If you want to take the 100k, it is a minus 20 dB. We have seen that one, minus 20 dB. If you want to cancel this one, yes, if you want to close that one, just 100 we can use that one. It is a 1000k. It is a minus 3 dB we have got, correct? Sorry, 100 get cancels 1000, minus 20 into 3 is 3. We got that one first. Here the 3 we got that one, that frequency. Otherwise, if you want to get the uh, yes, how much dBs, it is depends on the RF and R1. It is the closed loop curve, and this is a open loop curve. This is the frequency response. It is closed loop op-amp gain and the frequency response. This is the closed loop. It is downing like that. Open loop is like that. I have to see. Okay, within the required bandwidth. Op-amp gain bandwidth we have to calculate by these equations. This is the equations are very important for the to identify the equations. Hence, designing the an op-amp circuit figure known as the op-amp gain bandwidth product is important. The op-amp gain bandwidth product is generally specified particular op-amp loop configuration the output loaded. GBEP means gain bandwidth product into voltage gain into the cutoff frequency. We can call it as a cutoff frequency. We can call it as a cutoff frequency. We can call it as the gain bandwidth product. This is they can ask for your examination for the calculation. They may ask for this one. As per this, you are very important for that one. They may ask for this one for the calculation. Find out the gain bandwidth product of the frequency response. They may ask for that one. Gain they will give that, and the frequency they will cut off frequency they may give that one. For 2 marks it is very important for your exams. Yes, and then the op-amp gain bandwidth product is constant for the voltage feedback amplifier. However, it is not applicable for the current feedback amplifier because the relationship between the gain and bandwidth is not linear. Why? Because of that, it is the inversely proportional to the gain of the bandwidth. Therefore, decreasing the gain by factors 10 will be increases 10 will be increases the bandwidth by the same factor. It is I have already explained about this one. If it is the gain is increasing and the bandwidth is decreasing, right? Next is we have already discussed about this virtual ground. Now I am this is a different concept by this equation I haven't explained about before that one. Just a definition and how does the circuit it is there I have explained. Once again I am going to in um, briefly I am going to explain about this what is the meaning of the virtual ground. As the name is indicates, it is the virtual, not real ground. As the same purpose, one can consider it as the equivalent to ground in op-amps. Then term virtual ground means that the voltage at the particular node is almost equal to ground voltage means, for example, this is a circuit. This is called it as a virtual ground. This is called it as a virtual ground. It is not connected a ground, but it is there is no supply of the voltage. It is called it as a virtual ground. We are telling, right? Node means it is a point of the one or two points are joined. The ground voltage is zero. It is not physically connected to ground. This concept is very useful for analysis the op-amp circuits, and it will make a lot of calculation is very simple. Very simple means we have to calculate these equations by the many of the circuits we have to solve it by KVL and KCL law. At the same way we can explain it correctly using the infinite voltage gain. It is the I have already in the ideal characteristics of a op amp is the gain is infinity. I have explained that's why I took this circuit. We already know that ideal op amp we provide infinite voltage gain. For real op amp also the gain will be very high. Ideal characteristics it is not correct, it is not exact value, but as we are seeing in the op amp 741 also we can get the high gain of an op amp will be very high such that we can consider it as infinite for calculation purpose. Gain is a v naught by v in. Yes, as gain is infinite, v in is 0. If the v in is 0, there is no supply in the voltage of the that node. RF and R1 junction, we can't without v in is 0. V in is 0, V2 minus V1 are same or a 0. In the order of V1 is connected to ground, V1 equals to 0. Thus the V2 is also a grounded potential. Why it is the V1 is 0? V2 is also 0. V1 equals to V2, the both are 0. That's why the ground infinite voltage gain, we can see that one. It is the virtual ground. Why it is important? Why? Because of the many of the way we can gain is zero sometimes in the op amp, because it has a high gain. It is the infinity. That's why virtual ground is very important role to play in the 741 IC. Right. Next is a how the in this circuit we have to analyze it in the series order. Virtual ground concept is very useful in analysis of the op amp. One negative feedback is employed with the simple lot of calculations or derivations. Why it is the series? It is the negative feedback, it is there. That's why we are using the R1 and RFR. It is in the series, and mid one of that one is it is in the uh, it connects to ground is here. That is the role, it is called it as a virtual ground. This is a virtual ground. Yes, this is a virtual ground. V in and the V out. This is our resistance are in series. This is a very important role in op amp. Next is the difference between the virtual ground and the real ground. The virtual ground concept made by the for easy explanation and calculation purpose. By the easy explanation and the calculation, the gain of the op amp is very high. That's why the virtual ground is very important role to play in this concept. Real ground. Real ground is a terminal which is physically connected to ground or a earth, which acts as the reference point for the entire circuit. Real ground is terminal which is physically connected to ground or earth, acts as the referred point to the entire circuit. Means ground real ground concept, it is we can connect it like that, we can show, otherwise we can connect it like that with a reference of the symbol. We can really, it is connected, we can explain it. But in the virtual we can't express it. But we are telling that v minus equals to 0, v plus equals to 0, we can explain it, right? We can virtually we can explain it. But we are just telling that one, v1 v minus equals to 0, v1 equals to 0, we can tell that. But it is not shown any symbolical representation. There is no any symbolical representation in the virtual. Voltage is approximately 0 in the virtual ground. Voltage is 0 in the real ground. Real ground we can tell that one, it shows the in the image. We can for example in your any circuit you can connect the symbol of the ground. It is the voltage is 0, we can understood. Now the symbol nodile we can ground, it is connected, we can see that one, it is a 0. But it is a voltage is approximately 0, we can see that one. Not able to sink the infinite current. Not able to sink the infinite current. Correct, it is an infinite current sink. We can tell that one. V equals to I into R. Like, not electrically connected to ground. Not electrically connected to ground. Electrically connected to ground. With a symbolical representation, there is no voltage passes through here. It is we can connect it to ground. We can express it in the symbolically, and we can tell it, we can draw it, and we can express it in the real ground. In the virtual ground, we can't express like that. Okay, we can't tell that. Okay, that is the difference between the virtual ground and the real ground. This is also very important for your examination. Okay, keep it in your mind, differences and virtual ground, how it is connected, and this circuit. And in the frequency response is also a very important role to play in your examination. They may ask for your 5 marks or 2 marks. They may ask for definition or a whole circuit. They may ask for your, for virtual ground they may ask for only a 2 marks. Frequency response they may ask for 5 marks or 2 marks. They may ask for that one. Every day keep watching these videos regularly. It is help for your examinations. Okay. I will send the notes very immediately. Okay. First we have to, these two differences also they may ask for 2 marks, very important for your examinations. And it is your practicals also they may ask for these questions op amp based, because of the many of the experiments are based on your uh, op amp designing. That's why very important for your practicals and the theory exams also. Okay. Thank you so much for watching these videos, and keep watching the videos. Don't miss the classes. Yes, next class I'm going to explain about the applications of summing amplifier. I have already explained. In the next session I am going to explain about the differential amplifiers and the subtractor. Subtractor and the differential amplifier I'm going to explain about this. That is also very important for your examinations. Don't miss the classes. Keep watching the videos regularly. Okay, this is a very important unit for your examinations. Okay. Okay, thank you so much.